In this video, we will introduce the ANOVA F-test. We have studying the relationship between categorical variable to quantitative variable, where the categorical variable is the explanatory and the quantitative variable is the response variable. Specifically, we look at the inference for the two mean. We compare the two means with two independent samples. We also compare the two means with two dependent samples, and this is the case where we have the masked pairs. The procedure for the inference or statistic for each of these cases is different. Recall that when we compared the two means with two independent samples, we used the two-sample t-test, assuming that sigma is unknown. And when we compare the two means with two dependent samples in masked pairs, we reduce the two samples to one sample, where that one sample consists of the differences. As when we obtained one sample, we conduct the one sample t-test. Our next goal will be to compare more than two means. But in this case, we will assume these come from independent samples. So, for example, let's just say we are interested in the relationship between the IQ scores and the class standing. For example, if we want to know seniors in college are smarter, do they have a higher IQ score than freshmen? Then this is the categorical to quantitative variable, because the categorical variable is the class standing, which consists of freshman, sophomore, junior, and seniors. And in the response variable, we would compute the IQ score. We study the subpopulation, freshmen, sophomore, junior, seniors. In statistics, we would pick a sample of the subpopulation of freshmen, a sample of the subpopulation of sophomore, and so on. And in each of these samples, we will compute the statistics. Specifically, we will compute the IQ score, the average IQ score for the sample that we obtain from the freshman subpopulation. We compute except to bar the average IQ score for the sample that we obtain from the sophomore subpopulation, and so on. And so we obtained 4 sample means, and we will use these 4 sample means to infer something about the subpopulation means. Specifically, we want to know if the average IQ scores are the same or different. And the test or the procedure that we will use to carry such test is called ANOVA F test. ANOVA F test stands for Analysis of Variance, ANOVA. For the ANOVA F test, the procedure is very similar to the procedure to the hypothesis testing that we've done before. There are 4 main steps. The first step is to state the null and the alternative hypothesis. The null hypothesis is the statement of indifference. So in this case, we would assume mu1 equals mu2 equals mu3 equals mu4. Remember that we only have 4 subpopulations here. If we have n subpopulation, we would let mu1 equals mu2 equals all the way to mu n. When we conduct the hypothesis testing before, the alternative hypothesis consists of 3 cases: less than, not equal to, or greater than. But for the ANOVA F test, the alternative hypothesis is simple. In the null hypothesis, we assume that all mu's are equals. In the alternative hypothesis, we state that not all mu's are equal. This means mu1 is not equal to mu2, not equal to mu3, not equal to mu4. And this is always the case for the ANOVA F-test, where we state the null and the alternative hypothesis. In words, in the null hypothesis, it is the statement that all means are equals, and in the alternative hypothesis, not all mu's are equal. In the second step of the ANOVA F-test, we would compute the F-test statistics, where F equals the variation among the sample means divided by the variation within the groups. The F-test statistic is a ratio. We will go over the specific in an example where we compute the F-test statistics, but the next step is to compute the p-value, compare this to the significance level, and then lastly, we draw a conclusion. And so the procedure is pretty much the same as the hypothesis test that we encountered before. It's just that the specific in each step might be a little bit different, especially with the first step stating the null and the alternative hypothesis, and the second step where we compute the F-test statistics.